the amount of force generated by a muscle is a representation of how much cross-bridge cycling is happening. So the force generated by a single muscle fiber, and remember, within a muscle, we have many fascicles, we have many fibers, and then within a fiber, we have many myofibrils. So if we look at the unit of a single muscle fiber, the amount of force produced by a fiber is a representation of how many cross bridges are happening on the myofibrils that are within that single muscle fiber. Okay. The other factor that determines how much force is generated by a muscle is how many fibers are contracting. So not all fibers can contract. So that's kind of what I was just getting to when we talk about the difference between cardiac muscle and skeletal muscle. If I'm lifting a very light object, maybe one or two of my fibers need to contract to generate the amount of force that is required to overcome this very small load. If I'm lifting a heavier object, maybe a few more fibers will get recruited and they'll generate slightly more force, and then I'll be able to lift a larger object. So when you're lifting objects with your muscles, not all the fibers are always contracting. And this is where we can begin to speak about recruitment. So we can call on additional fibers to begin contracting as a way to recruit more cross-bridge cycling to happen and more force to be generated to be able to overcome heavier loads until we have maxed out all the fibers that exist within a single muscle. Okay. Now, the other factor that can increase how much force a muscle generates is the frequency of stimulation. So how fast are action potentials being stimulated onto the muscle? So if we increase the frequency of action potentials, we can increase the muscle contraction in two different ways. So the first phenomenon is called TREP, and then the second one is called summation. But let's talk about TREP first. So TREP is basically, if I stimulate one action potential, and this pink arrow here represents one action potential, is fired onto this muscle fiber, it's going to generate X amount of tension, and then it's going to relax. If I increase the frequency such that another action potential is fired in a short amount of time after, for some reason, the muscle is going to generate more force. Okay. If I do that again, the muscle generates even more force. If I do that again, the muscle generates even more force. And this phenomenon is referred to as TREP, and this will happen until the muscle plateaus, and that plateau is a representation of all the fibers being maxed out and the muscle generating the maximum amount of force that is physically possible for the number of sarcomeres that's present in that muscle fiber. Okay, so all the sarcomeres are shortening. All the individual myofibrils that have muscle fibers, let me say that again. All the individual myofibrils that have sarcomeres on them, they're all actively engaged, and the muscle couldn't generate any more force, even if we stimulated it even faster. Okay, now TREP is not fully understood, and the reason we don't fully understand the mechanism behind TREP is because in between each of these contractions, there is full relaxation and the tension goes right back down to zero. Okay, now this is really important for us to understand the difference between TREP and summation. So with TREP, the muscle fully relaxes. All that calcium goes back into the SR in between each of these muscle contractions. But for some reason, the next time the muscle is stimulated, it generates more force, even though it's starting from the same baseline that it did for the previous contraction. The theory of why TREP happens is because the machinery is already warmed up. So even though it's starting from the same baseline, this has just happened. So the machinery has been warmed up, and it's going to take a little bit less effort, and it will generate slightly more force for the subsequent contraction.